Hi, this is Brendan with Cusack Prep, and in this video we're going to be discussing composite functions. Now, in the last video we introduced functions and kind of how they operate. In this video we're going to talk about what happens when you combine two or more functions via a composite function. Composite functions are generally written one of two ways. They can either be written like this, where you have something like f of g of x, and that's how you say that. This is pronounced f of g of x. Or it could look something like this, where you have an f, an open circle, a g, in parentheses, and then an x. And just know that these two things mean the exact same thing. Now, before we start using the variable case, we're going to talk about simple numbers. So let's say I wanted you to figure out what the composite function f of g of -1 was equal to. Well, when evaluating composite functions, the key is you want to work from the inside out. So on the inside here, I have g of -1, and that's what I first want to evaluate. So off to the side, I'm going to figure out what g of -1 is. So g of -1, like we talked about in the last video, you make the substitution because -1 has replaced x. When you do so, you need to use parentheses. So we're going to have -1 squared minus 4 times -1 plus 2, which is going to give us 1 plus 4 plus 2, which we find out is 7. Now that we've determined that g of -1 is equal to 7, we can replace the inside part of this function with that value. So what I'm going to do is I'm going to say, okay, well, instead of f of g of -1, what is f of 7? Well, f of 7 simply means that we replace x with 7 in the f of x function. So instead of 2 times x minus 7, we're going to have 2 times 7 minus 7. Following order of operations, we would end up with 14 minus 7, which is just equal to 7. Let's try another example. So I could write any number of functions. It can be h, it can be f, it can be g. So because you're so used to using f of x, we're going to mix it up. And we're going to say g of x is equal to x squared plus 2x minus 4. And we're going to say h of x is equal to x minus 7. Now what we're going to try to do is we're going to evaluate two different composite functions. We're going to evaluate the composite function g of h of x, and we're also going to evaluate the function g of h, I mean to say h of g of x. Looks like hog x. So remembering what we discussed up here is we first work from the inside. So instead of x, before we get to that example, I'm going to put numbers in both of these. So I'm going to say we're going to evaluate g of h of, let's do 5, and let's do h of g of 2. So starting with this one, I first need to evaluate the inside part. Well, h of 5, that's just x minus 5, so since x is 5 here, 5 minus 7 is -2. Since we've determined that h of 5 is -2, this now becomes g of -2. Plugging -2 into the g of x function, we end up with -2 squared plus 2 times -2 minus 4. -2 squared is 4. 2 times -2, that's going to be minus 4, and then minus another 4. 4 minus 4 is 0, minus another 4 is -4. And that's how we would evaluate g of h of 5. Now over here, we're going to do h of g of 2. Remember, h of g of 2 means the exact same thing as h of g of 2 written this way. So just like before, we're going to start by evaluating the inner function. So I need to figure out what g of 2 is, and I know that that's going to be 2 squared plus 2 times 2 minus 4. Plugging 2 in to the g of x function. 2 squared is 4, 2 times 2 is 4. 4 plus 4 minus 4. This is just going to end up being 4. Now that we know that g of 2 is 4, we replace all of this g of 2 with 4. So what we're evaluating is h of 4. Since 4 has replaced x, h of 4 is 4 minus 7, which is negative 3. And there you have it. That's how you evaluate functions, composite functions that involve numbers on the SAT. In the next video, we're going to describe how to deal with this when instead of g of h of 5, you actually just have g of h of x and you have to figure it out. See you in the next video.